Seunghwan from KAIST, and today I will introduce a paper titled DocSeeker Structured Visual Reasoning with Evidence Grounding for Long Document Understanding, which was accepted to CVPR 2026 highlight. In short, this paper proposes a page-aware multimodal reasoning framework that teaches MLMs to first analyze the question, then localize supporting evidence, and finally reason over long documents more reliably. Before getting into the method, let me first explain what the paper means by a long document. A long document is not just a long sequence of text. It is usually a multi-page input that contains heterogeneous information such as paragraphs, figures, tables, and formulas, and in many MLLM settings, these pages are provided as images rather than plain text. Because of this, the model has to understand both textual content and the visual layout across many pages at the same time. The key point is that although pure visual MLM approaches are attractive because they preserve the full document structure, they do not scale well to long documents. This is exactly the motivation of DocSeeker, and in the next slide, I will explain the two main challenges behind this problem. Then the paper points out the two main challenges for long document MLMs. The first is a low signal to noise ratio called low SNR. In long documents, the crucial evidence is often buried among many irrelevant pages, so even if the model sees the whole document, it may struggle to focus on the truly useful information. The second is the scarcity of fine-grained supervision. Most existing datasets only provide the final answer, but they do not tell the model where the evidence is located or how the intermediate reasoning should be performed. So long document understanding is difficult because the model has to find sparse evidence with very limited supervision. So given these two challenges, the paper proposes DocSeeker, a structured reasoning framework for long document understanding. The core idea is that instead of directly generating an answer, the model first follows an explicit reasoning workflow. As shown in this figure, DocSeeker first analyzes the question, then localizes the relevant evidence pages, and finally reasons over the collected evidence to produce the answer. An important point is here is that the model is also page aware. Sorry. Each piece of evidence is tied to a specific page, which makes the reasoning process more interpretable and grounded. And then I will explain the detailed design of this reasoning paradigm in the following slides. Now let me explain the core reasoning paradigm of DocSeeker, which the authors called ALR, short for Analysis, Localization, and Reasoning. There are two important design choices here. First, the model uses a page-aware input representation. In other words, the input is not just the query and document images, but the query together with a page identifier for each page. So this helps the model associate evidence with a specific page rather than treating the whole document as one flat visual sequence. And second, the model follows a structured reasoning paradigm with explicit evidence grounding. In the think stage, it performs question analysis, evidence localization, and then the reasoning process. And after that, in the answer stage, it outputs both the evidence page numbers and the final answer. So the key idea is that DocSeeker is trained not only to answer correctly, but also to show where the answer comes from and how it was derived. This makes the reasoning process more interpretable and better suited for long document understanding. And then I will explain the how DocSeeker is trained. The model is built on top of QN 2.5 version VL 7 billion as the backbone model, and the training consists of two stages. First, in stage 1, the model is provides fine tuning on training data constructed through knowledge distillation. More specifically, a stronger teacher model, such as Gemini 2.5 Flash version, generates structured ALR style reasoning data, and this is used to teach DocSeeker the desired reasoning format. Then in stage 2, the authors further optimize the model with evidence-aware GRPO, which is a reinforcement learning stage designed for this task. The reward has three components. A format reward to encourage the correct ALR style, and evidence reward to encourage accurate evidence localization, and an answer reward based on final answer quality. So, so the first stage teaches the model how to follow the structured reasoning paradigm, and the second stage refines both localization and answer generation more directly. And this slide addresses a practical challenge in training on long documents. If we process every page at full resolution, the model produces a huge number of visual tokens which can cause GPU out of memory during training. To solve this, the main idea is simple. Keep the evidence pages at high resolution so that important details are preserved, while using lower resolution for many non-evidence pages to reduce the total token count. So this makes long document training much more feasible while still preserving the most critical information for reasoning. According to the paper, this strategy is used in both the SFT and GRPO stages, helping improve memory efficiency and the signal to noise ratio during training. And let's move on to the experiment section. These slides show the main experimental result of DocSeeker. The table compares DocSeeker with a wide range of prior approaches, including open source models, retrieval-based methods, and even closed source commercial models. The key result is that DocSeeker consistently outperforms its own baseline and also achieves very strong performance across multimodal long document benchmarks. Another important point is the comparison between baseline SFT, DocSeeker SFT, and DocSeeker on. Baseline SFT, which is trained only on short answer data, gives some gains, but much larger improvement comes from the ALR-based training. Then the GRPO stage gives more boost on top of that. So the main takeaway is that structured reasoning with explicit evidence grounding leads to great improvement. And this slide examines whether DocSeeker is robust to noise in long context. On the left, at, the authors evaluate performance as the document length increases. Here we can see that the baseline model degrades quite sharply as more irrelevant pages are added, while DocSeeker remains much more stable. This suggests that the DocSeeker is better at identifying the relevant evidence even when the surrounding context becomes increasingly noisy. On the right, the paper also evaluates DocSeeker in a RAG setting. As the number of retrieved pages increases, The baseline becomes more vulnerable to retrieval noise, but DocSeeker maintains strong performance and even benefits from being combined with a visual retriever. Finally, the DocSeeker is more robust in noisy long context and retrieval-based scenarios. And this slide presents the ablation study and helps clarify which parts of DocSeeker actually matter. First, on the left, the results show that ALR COT data is more effective than both raw short answer data and vanilla COT data. Also, as the amount of ALR COT data increases, the performance improves consistently. Another interesting result is that removing the page ID hurts performance, which suggests that the page-aware supervision is an important part of the method. And the second, on the top of the right, the paper compares different training resolution strategies. Here, EGRA performs the best, which supports the idea that keeping evidence pages at high resolution while selectively downsampling non-evidence pages is better than using a fixed resolution strategy. Third, on the bottom right, the authors study different GRPO reward settings, which shows that the explicitly rewarding evidence localization helps the model beyond optimizing answer correctness alone. So, this slide supports the paper's main claim optimizing answer correctness alone. And but the combination of structured ALR supervision, page awareness, EGRA, and evidence-aware reinforcement learning. And I will talk about the final takeaways. First, the paper argues that long document understanding is mainly limited by evidence localization. In, in other words, the key difficulty is not only producing the answer, but first finding the right evidence in a very long and noisy document. And second, structured ALR reasoning provides much stronger supervision than conventional short answer training. By explicitly separating analysis, localization, and reasoning, the model learns a more interpretable and more generalizable reasoning process. Third, DocSeeker shows strong robustness in long context and also works well together with visual reg. This suggests that explicit evidence grounding is useful for both end-to-end document understanding and retrieval-based settings. Therefore, the main message of this paper is that long document LLMs should not answer directly in a black box manner. Instead, they should first localize evidence and then reason over it in a structured way. Before finishing, I want to briefly show why the paper includes the secondary verification step in each distillation pipeline. On the left is a real reasoning error. The model follows the first model follows the format but reaches the wrong answer, so the sample should be discarded. On the right, the reasoning is correct, but the final answer differs only in format, so the sample is still useful and should be kept. This is why the paper introduces secondary verification to filter out true errors while rescuing semantically correct examples. And this slide gives a qualitative example of evidence localization in long documents. The baseline cannot answer the question, and the DocSeeker's SFT follows the reasoning structure, but it grounds the answer on the wrong page and therefore predicts the wrong position. The final version of DocSeeker model localizes the correct page and gives the correct answer. So this example highlights that Structured reasoning alone is not enough, and precise evidence grounding is the key difference. And this is the end of my presentation. And do you have any questions?
Thank you for your nice presentation. So is there anyone who have question from audience?
We can discuss question. Thank you for your presentation. I was wondering, you mentioned there is this issue with evidence localization, right? And
Yes.
so in these long documents, but is this really just a problem of this um, visual reasoning task, or is it in general when you have a long document, also with text?
Uh, it is provided in text.
Right, but so it's for basically when you have a long document, you have this issue of evidence localization, even if it's not with images, but also in text. Is that correct?
Yes.
Okay. Um, then maybe I also have another follow-up question. So I understand that this is about here the documents are images, right?
Yes.
And so I guess it depends on the kind of documents that you are dealing with. But if it's just a usual document with figures, it is very often a description about the figure already. So wouldn't be enough to just extract the text to be able to answer those questions? Or is there another reason why we are treating the whole thing as an image?
I think there is some noises. Can you repeat one more time?
Oh yeah, of course. So maybe I was wondering if you could explain me a bit more the reason why, or the motivation why we are treating the whole document as an image. Because if I think of maybe it's about the type of documents, I'm not sure, but if I think of any document, even if there are figures or images, there is usually a description. So wouldn't be enough to just extract the text to be able to to answer the questions.
Uh, just extracting text is fine with OCR based, but
Mm,
like multimodal sources like table or figure or uh, formulas in documents, it is distorted by only OCR based. So
mm,
currently many works uh, currently many works didn't use OCR based. They used document images as visual input, and they make the model interpret its own sources, not just only text.
okay, thank you.
Let's wait another 1 more minute. I think there is no more questions from audience, so it is a little early, but I think we can wrap up our today's reading group session. Thank you for joining our reading group session today, and thank you so much for your presentation, Seunghwan. See you next week.
Yes, thank you.